So you can take out your highlighter. What we are going to highlight, this doesn't quite match with your notes, does it?
It does.
Maybe, see, does this? There, this is what I want you to look at. That does match with your graphs, right?
Oui.
So we're going to get introduced to the word multiplicity. This graph has a 0 of multiplicity 2, and this graph has a 0 of multiplicity 3. And that is just based on how many times you have that x-intercept. So what would happen in this one right here, you could write this as, instead of writing x minus 1 squared, you could write it as x minus 1, x minus 1. And if you were factoring, that's what it might look like. And then if you solved for your x-intercepts, you would get x equals 1 twice. And so we say that that 0 of x equals 1, because it happens twice, we say that it has a multiplicity of 2. For the second function, if you got x minus 1 times x minus 1 times x minus 1, you would get that 0 3 times, so we would say it has a multiplicity of 3. So off to the side, I want you to make the following notes. What happens, and you might have noticed this when we did our examples before, when you have an even multiplicity? Does the graph bounce, bend, or go straight through? The graph bounces. Now that's not a mathematical term, but it seems to describe pretty good what happens. It bounces off of that x-intercept.
Better than just touches the x-axis.
Yeah, I like bounces, and you can make noises while you do it. It makes it more fun. Okay? If you have an odd multiplicity, an odd multiplicity always goes through. Sometimes it's straight through, sometimes it bends. So if you have an odd multiplicity, say, of 1, the power is 1, that's when it goes straight through. Anytime you have an odd multiplicity bigger of 1, like 3, 5, 7, and so on, that's when it bends. And it bends so much that it actually gets flat for a little moment. So you can have it flatten out right at that bend. So now when we're factoring, we first of all know the end behavior. After we know the end behavior, if something has a multiplicity bigger than 1, then it's going to either bounce or bend. And if the factor only happens once, it'll go straight through at that place. So when we get to example 3 here, the first thing you have to figure out is what type of graph it is and whether it's a positive or a negative. So for A, this is going to be an x to the 5 graph, quintic. And it's going to be positive because if you looked at all of the x's, here you're going to get a positive x to the 4, and here you get a positive x, and when you multiply those together, you will get a positive x to the 5. So we know the end behavior acts like a line. When we go to sketch this graph, these ones are nice because it's already factored, so we can draw our intercepts quickly. Our x-intercepts are going to be -1 and 2. Our y-intercept, again, you find your y-intercept by plugging in 0 for x. So if I plug in 0 for x, my first one is going to be 1 to the power 4. And my second one's going to be minus 2. And 1 times minus 2 is negative 2. So you need to label all of your intercepts, your x-intercepts and your y-intercepts. And then we know that our graph starts from down here. What's going to happen at minus 1? Bounce, bend, or straight through? Bounce. And what's going to happen at 2? Straight through. And when drawing your curve, you want to go through all the points, but you want to have your graph just naturally flow. So notice that when I graphed this, I made my minimum somewhere over here. It might have gone deeper than that, but when I was graphing, I'll do it again in a different color. So I'm starting from down here. I need to bounce off this one. I need to go through this point. You might feel a little bit stressed if you try to swoop up already, right? If I want to swoop through that point, it just felt more natural to keep going down. So try to just draw it naturally. And it doesn't matter where your minimum is. But that's why I didn't bounce off this one, because then I would be like, oh, seems a little bit sharp. For part B, first of all, what kind of function will this be? What power? X to the 4. Will it be positive or will it be negative? Negative. Because this will have 1x, this will have an x cubed, but you have a negative out in front, so that will make a negative x to the 4 graph. So we know that it acts like a parabola for its end behavior. When we go to sketch this one, your x-intercepts minus 1 and plus 3. Your y-intercept, this would be a negative times a 1 cubed times a negative 3. So it'll be positive 3 for your y-intercept. What's going to happen at minus 1? Is it going to go straight through, bend, or bounce? Bend. And then what's going to happen at positive 3? Straight through. My end behavior acts where it should. I go through all the points. I have bends and bounces where I need them. And straight through at 3. And this is sketching with the last thing that we need to learn about sketching, with bends and bounces. So, questions you can do. 9, 10, 11, and 12.